Welcome to the Beyond Tech podcast, a podcast designed for engineers. We aim to demystify technologies around safety and give you all the information that you need in order to make an informed decision when designing a safety system.
We cut through the fluff and we try and avoid those generic statements like robust and reliable. And we take a look at the technologies in the challenges of the real world rather than just looking at the data sheets that only references best case scenarios.
Each episode will take on one gas or flame detection technology and break it down, how it works, when and where to use it, potential drawbacks, and any maintenance requirements.
So under the umbrella of flame detection, we cover three technologies. We cover the infrared, the triple IR, UVIR, and visual flame detection. And this time we're going to look at the UVIR. And there is no better guest to invite on the podcast than Lars Wulf, our PM for flame detection. Welcome, Lars.
Welcome.
Good morning. Many thanks.
So how does the UVIR device work?
It is slightly a bit different to a triple IR because we are also looking on high emission of CO2, but we have two different sensor elements in the detector. It's an ultraviolet sensor and an IR sensor. And it is a combination that would be used to detect hydrocarbon fires.
How is UV different to IR? Like, what is the spectrum? How is it different?
It's on a different level of the wavelengths, to be fair. Normally, you're looking on higher wavelengths for CO2 emission on a triple IR and a much lower ultraviolet radiation on a lower wavelengths. So you have two different spectrums where you are looking, and the difference is if you get ultraviolet emission, it starts directly when the burning is started. Before you could see that with a smoke detector or other devices, you will get the ultraviolet emission, and due to this, that makes a detector really fast because you get the reaction directly in milliseconds. And that's different to other technologies.
Yeah, that goes to answering my next question, is why you would select UVR. So the speed of response is faster maybe than infrared?
Yeah, it is. It is faster. To be fair, at the end, if you have a combination of a IR detector and a UVIR, you need to have on both sensor elements a signal, so a high CO2 emission. Otherwise, you don't get an alarm. If it's only hot emission of an hot exhaust or other things that you have in an industrial environment, that is not covering a detection on the detector. So otherwise you always get problems with false alarms because you have a lot of hot sources in an industrial environment, and that makes problems then, of course. You need both.
In the triple IR, we spoke about how there was the three IRs, one being a reference. How does it work in the UVIR? Is there still a reference point in the detector or not?
The reference point is both different sensor elements.
So working together.
Yeah, they're working together. So you need a signal of both to get really a fire alarm or a flame alarm.
So speed of response, the reliability with the two types of technologies. Is there any other benefit or a reason why you would choose infrared? What was the maximum range? Is anything?
It's close to a triple IR, so it's the same detection range, but different could be the substances that could be detected. So for some substances, it makes sense more to use a UVIR than a triple IR detector. So it's always a decision that has to be made on site. Would it make sense to use one or the other one technology? So
could it pick up the new fuels like hydrogen and ammonia?
Yeah, you could. Technically, you could pick up hydrogen, of course, with a UVIR, but that is not the best choice. It's much better or much safer or reliable to use a triple IR because then you have measurement wavelengths and two reference to cover these hydrogen detection, and that's the better choice. You could use that with a UVIR, but our decision was made not to do that. We are focusing on the hydrocarbons for the UVIR.
Are these detectors susceptible to reflections, like off metallic structures? Does that cause any problems?
Yeah, for an IR detector, it could cause problems. So if you have reflections from hot CO2, that could be a problem. For an UV detector, it's of course if you have arc welding, lightning, so direct lightning or something like this, that could cause some problems because you have a hot UV IR radiation, and that of course gets a signal on the detector.
Yeah.
So due to this, you need a good algorithm in the detector itself to cover that, because you need the information from both. And due to this, maybe use it like this: you have the strength of both technologies in one detector.
Yeah.
And due to this, you're much safer than if you only use once. If you have a single UV or single IR, you're always struggling with some environmental problems. And if you combine that, you have the best choice in a mixture.
So do these detectors go through a lot of testing and have like a big catalogue, so to speak, of errors and like things that could go wrong to kind of counterbalance?
Yes, of course, they are going into, if we are doing a performance approval on these kind of detectors, you have to do a mixture of different substances, of course, to detect on different detection ranges and big or small fires, of course, in the combination with environmental effects. So meaning you get maybe
heavy rain, snow,
all these things. That brings us to the situation that you all the same have as on triple IR. You have to cover the unit maybe if you have a harsh environment, and of course you have to be on a safe side. There should be nothing on the lens of the detector, because then maybe you get in trouble. You don't get the emission to the detector because it could be blocked to something on the lens.
Is the field of view of the UVIR similar to that of the triple IR? Is it again a cone shape?
It is a cone shape. It's a bit different, but it's really close to a triple IR. It is a bit, just a small difference, but it is also a cone shape, and that brings us to the situation that in the cone it works perfectly, but if you go to the edge of the cone, it's a weaker signal. And if you go to the end of a detection range, maybe for a hydrocarbon, a typical detection range could be around about 50 meters. So if you go to the end of the detection range and you have a small fire, it could be not so easy to detect, or it will take longer time from the response time perspective to get that.
Yeah. So you want to be comfortably within that range in the middle of the cone as well.
Yes.
So what sort of size of flame are we looking at or using as a measure for minimum detection?
So a standard fire is a small pan of 30 centimeters to 30 centimeters. So that's a standard fire that could be used. It depends. So if you have the fuel as a gas, or if you have the fuel as a liquid, so that's different, of course, at the end. So there are two different procedures that would be tested. But a small fire could be detected in the whole detection range that would be tested during the detection range.
Throughout the distance?
Yes.
The visible
Correct.
distance, yeah.
So.
Okay.
And what is more dangerous, like a gas fire or a vapor fire? Or can they just both be catastrophic?
I think a gas fire would be more critical.
Okay.
So in terms of installation, we've looked a little bit around the environmental conditions. Is there anything else we need to look at when installing?
Yeah, when installing, of course, it should be without any vibrations on the detector itself, because then you get a bit of a misalignment of the detector, and of course you get in trouble because the signal would not be stable.
Yeah.
You should be cover the unit itself if there is maybe a lot of fog or rain in the area, and due to this it makes sense to cover the unit itself and to cover the lens. Then a weather shield could be a good choice. Also the mounting position would be good, to use it on a higher amount and looking downwards. Due to this, there is no water on the lens because it's going down of the unit itself. It's not coming to the lens. So, and that will cover also the area. And of course, it should be a free line of sight. So otherwise you could not see the fire. You could only see what it's in the field of view. Outside the field of view, you don't see the fire.
Okay. And I guess that's where gas mapping would
be a good choice. Would be really a good choice to find the right setup, of course.
Okay. So you don't need physical access when calibrating?
A physical access to the unit itself, it's not needed.
Yeah.
Normally, you could do that remotely. There's a flame simulator that we used for this that activates the alarm on the detector itself. So it emits high ultraviolet emission, and also for the IR for CO2. And we have, for the IR version, we also need the flickering of the fire itself. Otherwise, it's not detecting an alarm.
Okay.
So, and that will be done by the flame simulator. And due to this, it's the easiest way remotely to activate the device and try out if everything is correct and you did the right setup of the detector.
So is the flame simulator the same for triple IR than it is UVIR?
Yes.
It is.
It is the same simulator that could be used.
And then going forward in terms of calibration, what's the recommended frequency?
Normally there is no calibration needed because all the flame detectors are factory calibrated, but it always depends on the environment.
Yeah.
So if we have a harsh environment, it would be recommended to maybe once or twice a year to go to the unit, to check the unit itself, to clean the lens, and also to do auto calibration via the flame simulator, just to be on a safe side.
Yeah.
And you have to keep in mind, if there is a change maybe from customer side to a new setup, to a different detection range, to a different substance, whatever, then of course you could change it on the unit itself. And then it makes sense to do a recalibration and to check the unit after you do the new configuration.
Okay. Just going back to the what can affect or give a false alarm to the devices. You mentioned arc welding. What happens when you have to perform some welding in the flame? Do you just isolate that device, or?
Yeah, I think the best is to isolate the device. If you know that there could be a problem, then also you could use or maybe use a mixture of different devices and have a smaller detection range.
Okay.
Maybe to cover a smaller area, but then to be on a safe side, not having the whole detection range and then getting in problems because there are some sources that could activate the unit for a false alarm.
Okay. So we look to have three kind of takeaways for the viewer. And I'll start with the first one. So when would the ultraviolet or UVIR sensor be selected? When would that be the correct choice over the other devices?
I think depends on the substance itself. So if there is a special substance, and the second part is if we need fast response times.
And when you say special substance
that could not maybe good detectable via the triple IR unit.
Okay.
And then the second question is a limitation that people often forget.
Maybe the field of view, just looking into the field of view, that you only could see a fire if you're in the field of view, not on the edge of the field of view or outside.
Okay.
And then the one thing people should remember when looking at maintenance.
Cleaning the lens, of course, checking the unit with a flame simulator. So these are the main topics here have to be covered.
Yeah.
Excellent.
Good.
Thanks, Lars.
Many
So that's the end of another podcast, Beyond Tech podcast. If you are working on a project and you need a deeper insight into the technologies you're looking to specify, then you can go to our website, Dräger.com/EPC, where there's a whole library of technical documentations you can use.
We hope you found this podcast useful or beneficial, and don't forget, when it comes to the flame detectors, we have 3 episodes for each of the technologies, so be sure to check out the other episodes if this was not the one you were looking for, but it should have been.
As Megan said, the next episode is another technology, but the rules are the same: no products, no fluff, and we look at real projects.
Yeah, thank you.
Many thanks.
Thanks.